Since 1977, the Saba Lions Club has been a pillar of service and community care on the island. What began with 20 committed members has grown into a legacy of giving back, supporting those in need, and advancing the global mission of Lions Club International. From cultural events to signature service projects like Meals on Wheels and the Food Bank, the Saba Lions Club supports the elderly, disabled, and struggling families with compassion and consistency. Their health programs, like annual eye care support and glucose fairs, continue to promote wellness across the island. The club is also a champion for the environment, proudly maintaining an adopted hiking trail and backing local cleanup efforts to protect Saba's natural beauty. Several of its members have been honored with the prestigious Melvin Jones Fellow Award for their outstanding dedication, proof that the spirit of service is alive and well on Saba. The Saba Lions Club, serving with heart for the good of all.
Good evening, everyone. Let's hear it for the Lions Club. The Lions Club is part of the reason we can do live streaming. So hello to our home audience and everyone at the beautiful Calibre Cafe. We're a little bit of risk takers, so we didn't want to move the presentation tonight. So I want to hear everybody go, okay. No rain tonight, but we must say, if it by chance does start to rain, what you can do to help us is stay out of the way, because there's a lot of expensive equipment. The speaker will need to protect his laptop, and we're going to need to move around, so just don't be an obstacle, okay? Thank you. So let's get started. Our program is made possible, as you can imagine, a month-long event. It takes a lot of coordinating, but also a lot of funds to make happen. And it would not be possible without our primary supporters, the Culture Fund of the Caribbean, the Nature Environmental Policy Plan, and public entity Saba. Let's hear it. Over our 22 years, we have grown from 5 original sponsors to almost 60. I don't know who's moving my slides, but I'm not. So if you see any of these sponsor logos that you recognize, by all means, thank them for their support in making this possible. The Cottage Club is the sponsor of tonight's speaker. Yes, it is. Sorry, excuse me. The Cottage Club is a great supporter of the See and Learn Foundation in general and has specifically sponsored our speaker this evening. And if you haven't heard, we have a great raffle. If you saw the loop slides, then you saw all the incredible, almost $10,000 worth of prizes that you can win for a mere $5. So see Emily or me after the show at our office. You can also purchase tickets at Sea Saba Dive Center. The funds for the raffle this year are supporting our Critter Quest scientists coming back this winter, January, February, and March. So we have a goal of $5,000 to augment and offset their expenses. We are presently just under $2,000, so every ticket matters. So give to a good cause and have a great chance to win. If you participate in a field project, Vincent is going to tell you about his field project as part of his presentation, and that takes place tomorrow afternoon on the Sea Saba dive boat at 1 o'clock. If you want to join us, you have to tell us. If you need taxi transport, we'll explain all of that to you. And once you hear his presentation, I'm sure you're going to want to join us. And that's our next field project for tomorrow, but you need to sign up. On Friday evening, our next presentation will be at Liam's Cuisine with our next star expert, John De La Costa, who's in the audience. Let's hear it. And you're not going to want to miss his very interesting presentation about our night skies, and join his field project as well, which will be on Saturday. If you join a field project, you get an awesome free hat. Our hats are sustainably created. There's a choice of a bucket hat or a baseball hat, but you have to earn it. So before we get started with tonight's speaker, because it's about Sargassum weed, when I first moved to the island in 1989, about a year or 2 or 3 later, we had our first Sargassum event, and we were so excited because we realized it's its own ecosystem, and you could find Sargassum frogfish and cool, all kinds of cool, interesting stuff. So we used to tell people, hey, if this happens, it's really exciting. Make sure you swim over and look at it. But now it's happening a little too much. So we're going to do our proper introduction now. So just here we go. From restoring oyster reefs to rethinking seaweed, Dr. Vincent Encomio is helping Florida's coastlines thrive from the ground and water up. As a Florida Sea Grant Extension Agent with the UFIFAS, Vincent partners with communities around the Indian River Lagoon to tackle coastal challenges like stormwater runoff. Hold on, Emily. Can you stop that from happening, please? From stormwater runoff, harmful algal blooms, and habitat loss. With degrees in biology and marine science, he leads citizen science programs that engage locals in monitoring water quality and restoring key ecosystems like oyster reefs, mangroves, and seagrass beds. Most recently, he's been working to find sustainable solutions for the excess Sargassum seaweed piling up on beaches, studying how it can be composted or converted into biochar to fight pollution and store carbon. Thanks to Dr. Encomio's work, these stinky situations are getting a fresh algorithm proving that even the messiest marine problems can lead to smart, science-backed solutions. Please join me in welcoming Dr. Vincent Encomio.
Thank you. Is the audio coming through? Test, test. Good? Oh, good, good. All right. Let me make sure I got this right. There we go. Okay. Great. Well, thank you so much, and thank you, Lynn, for the introduction. It's great to be here. This is my first time in Saba, so it's beautiful. I'm just so blessed and thankful to be here. And as Lynn mentioned, Sargassum probably isn't a new thing to you guys. It's obviously an issue in the Caribbean in general. I'm going to talk about a bit about how we got there, and some of the things that people are doing, a little bit of work that I'm involved in, but also what other nonprofits, companies, universities are doing to kind of help address the problems that we're having with Sargassum. Because in Florida, it's occasionally a problem, but in the Caribbean, I think it's perennially a problem. It's an annual thing that doesn't look like it's going away anytime soon, unfortunately. So where do we start? We start here. Lynn was mentioning that they were encouraging people to swim or snorkel in the Sargassum when they see it. because of all the incredible wildlife, the fish and invertebrates that are associated with the Sargassum. I actually have a little handout if you want to take it before you leave tonight, and it kind of shows some of the iconic species that are associated with Sargassum. There are over 60 species of Sargassum seaweed. Most of those are anchored to the bottom with holdfasts, like if you think of kelp in California. But in our area, we have two floating species of Sargassum that are the only floating species of Sargassum in the world. So two species, and there's actually there's two types of the species on the left, Sargassum natans. And I actually also have another handout up front that if you want to see what those look like, you can take a look at. And on the field trip tomorrow, we'll see if we can find the different species of Sargassum. But it's because of, as you can see from the picture, the diversity that it supports, the habitat that it provides for all kinds of different animals, over up to at least 300 species. It's known as a golden floating rainforest. So incredibly important for biodiversity. Carbon sequestration is, I'll get into that in just a little bit later. But where it's primarily, or was historically primarily known to occur, is right in the middle of the North Atlantic Gyre that's called the Sargasso Sea. So the Sargasso Sea is unique in that it's the only sea that's bounded strictly by currents. It doesn't have any landmass that it's associated at all. It's strictly the currents that make up that North Atlantic Gyre that create the boundaries for the Sargasso Sea. First described by Christopher Columbus sailing across. Another thing about that parts of that area, and around 30 to 35 degrees north latitudes, is that an area that those are called the horse latitudes. Does anybody know why they're called the horse latitudes? So the reason why they're called the horse latitudes, those are areas where the winds, it's primarily dry, winds are calm. So it was an area where when people were sailing across the ocean from Europe, this was an area where they could be dead in the water from the lack of wind. And if it happened for too long of a period of time, and they were bringing horses from the New World to the Old World to the New World, they would might have to dump their horses overboard because of the amount of water that they had to ration out. So that's why it's called the horse latitudes. So, and in that area is where you'll find a lot of Sargassum seaweed. So hence the Sargasso Sea. The other thing that the reason why it's called the Sargasso Sea is when Columbus sailed across, it reminded him of these tiny grapes that they knew about in Portugal called Sargasso. So that's how the name has stuck. And so described in by Christopher Columbus in literature. This is 20,000 Leagues Under the Sea. I won't read the whole thing. By Jules Verne. So it's kind of captivated people's imagination in different ways. And then moving forward into modern times, if you ever read any of these comic books, this was in this issue was the story called Secret of the Sargasso Sea. And if you remember Donald Duck, if you remember his Uncle Scrooge was always coming up with get-rich-quick schemes, and this was one of the schemes, was trying to go to the Sargasso Sea, look for treasure, find something valuable in the middle. I think it ended with Donald Duck being deserted on a desert island. So anyway, I love comic books. That's why I put that in there. But so the other thing about those two species of Sargassum, the reason why it can get so thick in the middle of Sargassum Sea is primarily those two species are reproducing vegetatively or asexually. So a fragment breaks off, that fragment grows, another fragment breaks off, that fragment grows. I'm stealing this line, but these two species of seaweed haven't had sex in over 200,000 years. I won't go into any more than that. So, but anyway, this infographic kind of shows why the Sargasso Sea is so valuable. Again, it's that golden floating rainforest. It creates all this habitat for all these different species, supporting fisheries, supporting biodiversity, iconic organisms like that Sargassum frogfish. I remember talking to someone a couple nights ago about eels. So the eels, they kind of do that opposite migration in their life history compared to, say, fish like salmon, where the adult salmon will return to the streams and rivers that they were born in and will spawn there. Eels do the exact opposite. So they'll come out as adults to the middle of the ocean, looking for the sargassum in the Sargasso Sea, give birth to their babies, and those baby eels will swim back to those original streams. And an incredibly valuable fishery, which unfortunately is fraught with some overfishing and poaching and things like that. But all of those things, I'm not going to get into all the numbers there, but in addition to all the fishery benefits that it provides, there's all kinds of other benefits. Regulating climate, it's taking in carbon dioxide because seaweed photosynthesizes. All that biodiversity it has enormous value. And then all these other services, ecosystem services. Ecosystem services really means the benefits to us, to man. Nutrient cycling, it's taking up nutrients, keeping those in the tissue, keeping those excess nutrients in the tissues of the seaweed, purifying the water in that process, and I'll get into a little bit of that, taking up things like metals and excess nutrients, and then all the habitat and nursery service provided. In total, in the Sargasso Sea, it's estimated that those ecosystem service benefits are valued at nearly $3 billion. So incredibly, incredibly important. And I'm going to get into how did we get to this situation, or one of the hypotheses about how we got to the situation in the Caribbean with Sargassum seaweed. So Sargassum, largely known to be occurring in the middle of the Sargasso Sea. Occasionally, you'd get some of that would through currents and winds and storms make its way out and occasionally inundate places like Florida and places in the Caribbean. It could get entrained into the Gulf of Mexico. I'm probably supposed to say the Gulf of America, but I'm going to say the Gulf of Mexico. I will say thank you for that. The Gulf of Mexico, it can make its way traveling on coastal eddies and small mini gyres and get entrained in the Gulf of Mexico, and then it would become a problem for beaches in Texas. So they do regularly deal with this as well. And then some of those eddies would get advected in the Florida current, the loop current, which comes around the tip of Florida, and then it could either get beached again in Florida or make its way back out to the Sargasso Sea. There's actually studies that show or that indicate that that's one of the main ways the Sargasso Sea gets fed, is when sargassum gets into the Gulf of Mexico and then recirculates back out into the Sargasso Sea. It's providing new feedstock for that sargassum seaweed to keep growing, and that's actually an important characteristic that's going to get us to where where we are in the Caribbean now. Analogously, we have a similar situation. So in 2009 to 2010, this is the graph you see up on the left is a graph of what we call an oceanic phenomenon called the North Atlantic Oscillation. Okay, and the North Atlantic Oscillation is basically, it's an indicator of the difference in surface level pressure between the Azores Islands and Iceland. So it's kind of like a seesaw pattern of pressure. The most famous type of oscillation that you may have heard of is El Nino. Okay, so it's an oscillation of pressure between two locations in the Pacific Basin. In this case, in the Atlantic, It's between an area near Iceland and the Azores Islands. And so what that tends to indicate is that it can dictate our climate and our weather for in any given year. So if you can see the shaded area in yellow and that blue negative peak, that blue line going down, we had a highly anomalous negative index of the North Atlantic Oscillation in that winter, around that winter of 2009, 2010. And what that meant is that the jet stream came further down south. It started moving sargassum further eastward. Again, this is a hypothesis. The hypothesis is that that negative NAO index was an indicator of that jet stream moving further south, those winds blowing more of the sargassum eastward. Somewhere around 2010, I believe, is the first recorded, or what was believed to be the first recorded beaching of sargassum in West Africa. Okay, so it made it into an area that it normally wasn't found. It started riding some of those currents that are part of the North Atlantic Gyre, the Canary Current and the North Equatorial Current, getting into this area known as the intertropical convergence zone. And there it stayed. To the point where now we see sargassum in a relatively new area. So there is an alternate hypothesis in that there are one particular morphotype of sargassum was always in background levels found in the tropical Atlantic around the equator. But as you can see, if you look at the graph above, there's very little, it's representative of biomass of sargassum in this Caribbean Sea and the Central Atlantic Ocean, very low prior to 2011. And then we started seeing more frequent biomass or increased biomass past 2011. And then in 2018, it just went nuclear. So incredibly high biomass of sargassum seaweed in 2018. I think they estimated over 20 million tons in this area. That is now a new area of sargassum known as the Great Atlantic Sargassum Belt, the largest macroalgae or largest seaweed bloom in the world. So over 5,000 miles stretching from Western Africa to the Gulf of Mexico. Now it's a almost a near annual occurrence, and that's where we are. And the main thing is that the main problem is that it got down there and it's staying. And one of the reasons why they think it's persisting is that a scientist by the name of Dr. Brian LaPointe has done some study. He's been studying sargassum for a long time. He's looked at nutrient concentrations within sargassum. You can look at different isotopes of nitrogen and phosphorus, and it's shown that since that 2000, over a period of time, actually, I forget how far it goes back, but he's seen increased enrichment of nitrogen in those sargassum tissues. And his hypothesis is that a lot of that sargassum now is being fed by Amazonian basin runoff. So that's a lot of nutrients coming out of the Amazon basin. They've seen, I don't have a graph of it, but preceding those spikes were spikes of nitrate, which is the most usable form of nitrogen for plants, spikes of nitrate a year or sometimes a year or two prior to these large growths of sargassum seaweed. Yes? So the question was, is it agricultural runoff that's causing the increase in nutrients? Yes, that's primarily the thought, is that it's a lot of it's from agricultural runoff. There may be runoff, and I'll get into it later. There mining operations, mine tailings, that kind of thing. But a lot of it is thought to be agricultural runoff. Yeah. Well, I don't know if there's any golf courses in the Amazon, but certainly in Florida. So where we're at now, as a near annual occurrence, this is what it looks like. This is sort of the monthly averages of Sargassum biomass from 2010 to 2018. And if you look at the top left is January, so the start of the year. And really all you need to look at is the change in color. As it gets redder, that's more Sargassum. And you see increases starting around May, all the way through the summer months, starts to recede a bit as we get into the fall months, and really dies down as we get closer to the winter. But the important thing is that no matter how much it dies down, there's a remnant population all the time now. And that's that seed for that next year, So now we have two areas in the Atlantic and the Caribbean that are major ecosystems for Sargassum. We still have the Sargasso Sea, and now we have the Great Atlantic Sargassum Belt. So just two huge areas. So, and the downside of the Great Atlantic Sargassum Belt is you can see the currents, see the winds are typically going east to west. What's right in the path of all those currents and winds in the Great Atlantic Sargassum Belt? Places like here. Yep. And the other thing that probably I think seems to be a generality within all the islands, your east-facing shores, your east-facing embayments are probably and that seems to be based on what I'd look at the map and see where it is. That's typically where you're going to see these beachings and these accumulations. And this is just a cartoon showing how that happens. We've got perennial sargassum in the Great Atlantic Sargassum Belt now. That kind of gets closer, can raft off and get closer to shore, and then eventually find its way to the beach. If you can make out some of the little cartoons or the little icons in the infographic, you see a front loader moving sargassum, a guy raking it up or shoveling it up, and then you see a guy coughing. So what happens is the sargassum will get on the beach, and you guys have probably all seen this, you've experienced it. It just overtakes that beach. It starts to decompose. Within 48 hours, it's going to start decomposing, and then you'll get that rotten egg smell, that hydrogen sulfide, and that's a real problem because that is poisonous. So that will affect us. So people you'll get headaches. People can get very sick. You could even if it's so bad, if you're exposed to it, and you think about people that are tasked with trying to remove it by hand, they could even get very sick and faint and possibly even die because hydrogen sulfide is very toxic. It's very toxic. There's been a few studies in Martinique and Guadeloupe where they're showing that the hydrogen sulfide levels were so high that people there were getting sick. There was a potential higher risk of pregnancy complications in women from Martinique the closer they were to the beach. So there's all kinds of ecological issues when it gets, and I'll show that in a second, but also human health issues with regards to these beachings. And this is just an example of what some of that could look like. A couple of these places are very close. Barbados seems to be the front line nation because they're the furthest out. And so there's been a lot of work being done in Barbados. And I'll show you a little bit more about that later. But you can see that video in Grenada, and you saw the boats out there. Those boats can't get out to go fishing. They can't. So that's almost like completely unable to be utilized. And so with all the different impacts, I mentioned human health effects, decomposition on the beach, the cost of trying to remove it in 2018, which still remains the biggest year for inundation of sargassum in the Caribbean. Caribbean-wide, they estimated it was $120 million to clean it up. And that's not counting the lost income from tourism, loss of income from fishing, all the maritime activities that in the nearshore environment that are important to all of these nations. But then ecologically, you could have sargassum once it starts to decompose very close to shore, maybe not on the beach, but it can smother seagrass beds. I was talking to somebody yesterday from the Sabre Research Foundation that a recent beaching or recent decomposition sunk down over some of the elkhorn coral in the area and killed the coral. So I didn't have a picture of coral, but just like the seagrass, that decomposing sargassum can choke out all those other valuable habitats like seagrass and coral. Then also close to the shore, as it decomposes, it can cause water quality impairment, lower dissolved oxygen, all those kinds of things which are going to be bad for fish. And then, of course, you saw the video in Grenada where the boats can't get out in the water. And then tourism. 80% of the Caribbean's GDP is based in tourism. So if you have a situation like this where you can't enjoy the beach, you can't enjoy the water, or you might not, people might decide not to go there. So, and all of these impacts classifies sargassum, at least when this happens, we recognize it now as a harmful algal bloom, because sargassum seaweed is an algae, it's a macroalgae, and any algal bloom that produces toxic or harmful effects on human health or animals or aquatic ecosystems is classified as a harmful algal bloom. And sargassum now is, at least when this situation happens, is a harmful algal bloom. And that's kind of where I got involved in all this, is as I've been doing work in Florida. We get hit by a number of different types of harmful algal blooms, mainly microscopic algae, phytoplankton, that are toxic. If you heard of red tide, that's a well-known one from Florida. So I've been doing work, citizen science work, education, much like this, on harmful algal blooms. And that's kind of how I got involved with sargassum. So I mentioned the heavy equipment. This is another example from Barbados, trying to remove the sargassum. The problem with heavy equipment is, one, it's compacting the beach. When they remove it, it can also take a lot of sand with it, so it's also contributing to erosion at that particular beach. So a very incredibly important problem. This is some of the numbers from 2018 in a few locations. The Yucatan, that area of Mexico, is just devastated by this. So these are the costs to remove sargassum in 2018, and the coastlines that they had. So a very high cost. So that's been the standard way to try to remove sargassum. Other companies have looked into possibly removing it before it gets to the beach. So that's one. This is just one example of that. In the U.S., that's really not possible, because sargassum has been, because of its ecological importance, has been classified as what they call essential fish habitat. So a habitat that's necessary to support fisheries in important stages of their life cycle. So it's an important nursery habitat. So that's not something that's really an option in the U.S. at this time. But one company at least gave it a shot. They probably had to go through a lot of permitting to try a floating boom system, and this is in the U.S. Virgin Islands. Again, this is in an embayment on the eastern side of the island. And so one of the things that, some unintended consequences of trying to capture it before it reaches the shore, are there still valuable species, important natural resources in that sargassum? And some of those questions are still just beginning to be answered, not really rigorously looked at this time. But anecdotally, this is a screenshot from a NOAA webinar that was given earlier this year. But in some of the sargassum that's bumping up against those floating booms, you do see important species. Protected species like juvenile sea turtles, baby sea turtles. That's the sargassum frogfish right there. Juvenile lobster on the left. So that is something it makes it a challenge when trying to remove or control sargassum when it's out in the water. So for now, this is kind of the reality that we're faced with. More so in the Caribbean than Florida, but we regularly get it as well. So what to do about all this? Well, there is the potential. Some of these options are actually being done. Some of them are just pointed to as potential uses of sargassum. So you've got, and I'll show them a little bit later, but there's potential to use it for biofuels, energy, other examples where they show the sheep. There's seaweed in other areas, other countries that are being added as additives to their cattle or sheep feed, and that's that. And I'll get to that towards the end. That's been important as not only for nutrition but for other reasons too. There's other sargassum species have been in other countries have been used for nutrient supplements. Fucoidins is a chemical that you can extract from seaweed, and it's thought to or purported to have anti-inflammatory properties or characteristics. There's a company in Mexico that's making paper and notebooks out of the sargassum. So there's a wide range of potential uses of all this excess seaweed. I'm going to point to the top right really quick. That was the first thing how I got involved in looking at sargassum was can we use it? We're getting it from the beach. I'm an extension agent. So an extension agent, we work with local communities trying to help provide guidance that are science-based to any number of different things. The extension model is the tradition is extension agents. We're there to support agriculture. It's since evolved, especially in urbanized areas. But I would get questions from gardeners saying, "Hey, can I use this sargassum for their gardens?" And they heard it might be a great fertilizer, might be great in their soil. So that's kind of how we got involved. We did a small pilot project where I collected the sargassum. This is from a dumpster. There's a nuclear power plant in my area of Florida where the intake water to cool the plant was starting to get inundations of sargassum. And so they developed a netting system. They're mainly there to capture protected species, especially sea turtles. But in recent years, they've mainly been catching a lot of sargassum. And that's important. They needed to have a system to be able to capture it and remove it. Many years ago on the west coast of Florida, there was a nuclear power plant that had to shut down because of excess sargassum getting into their intake system. So that was a free and easy source of sargassum for me to utilize, to look at different ways to compost them. Essentially, we just took different proportions or percentages of sargassum, mixed it with chipped tree waste. And one of the reasons why we were very concerned about exploring whether sargassum could be composted is because sargassum naturally accumulates arsenic from the environment. So that was a concern. If someone's using it in their garden to grow their tomatoes, what are the risks of that? So we wanted to look at different proportions of sargassum and over time and see the main thing was really to look at the arsenic levels in the compost as it developed. So we did this over a course of about 4 months, 120 days. This is just a graph showing sargassum content in each of those lines, and the colors are different percentages of sargassum within those compost mixes. Martin County is where I am. It's about a couple hours north of Miami. Monroe County is the Florida Keys. So wide variation in arsenic content when you collect it from the beach. anywhere from mine was relatively low to almost getting into samples that were 100 parts per million. That's milligrams per kilograms is parts per million. And dietary guidelines for arsenic are in the parts per billion. So this is an order of magnitude where you might consider it safe, you know. So, but one thing that was promising is arsenic levels dropped quite a bit over time as the mixes were being composted. So, and some of it's kind of occluded a little bit, but that line, that dashed line, is the recommended limit, upper limit for arsenic as recommended by the U.S. Compost Council and the EPA. So below that, you're kind of in a safe zone to use it for municipal, industrial use. Still not so much for residential use. Your residential safe zone is going to be probably right around here, about two parts per million is where it's considered safe. At least in Florida, it's safe to use in your residential applications. Yes.
Like at day 0 on Monroe County. Sample error?
Oh, you mean that's just variation between the samples. It's just highly variable. Not only within individual samples, but then as you can see from one geographic area to the air. Why that is, we're not really sure. So, but that's a great question. The question was, where does the sargassum go if it's not in the compost? I believe it's being leached into the soil below, more than likely. So we still have a problem. Yes.
Is not good.
Not good. When people call me and ask whether they should use it, I think for the most part it's okay for your non-edible landscapes, but I've stopped short of recommending it for gardens where you're growing food. Okay. So I was telling them a story a couple nights ago. There was a blogger who does a lot of foraging in Florida, and he had a couple recipes for sargassum in his blogs, and I had to write him and tell him, please don't do that, because we're finding still high levels of arsenic in it. And he never got back to me, but I hope he's okay. I just hope he's okay. But anyway, so that work, looking at whether sargassum could be composted, kind of led to this next step. I got connected with the scientists at the Florida Institute of Technology, another university in Florida, and he was interested in whether sargassum could be made into biochar. Has anybody heard of biochar before? No. So, great. That's awesome. So biochar is really a highly purified form of carbon. Think of activated charcoal, but even purer than that. So, and that's the picture on the right, is one example of that. So you can take that sargassum, convert it in intermediate steps all the way to what you would consider biochar. And really what biochar is, any organic material that you combust at super high temperatures in the absence of oxygen. It's what's called pyrolysis. So this biochar was produced at a range of temperatures from 400 to 800 degrees Celsius. So they have in my colleague's lab, he's got a mini micro furnace that could combust organic material at 800 degrees Celsius up to that. The intermediate one is about anywhere from about 200 degrees Celsius. What he's finding is that the hydrochar, what he's called that sort of intermediate between the raw material and biochar, is still has some value and is usable. But what's known about it, you have a high carbon content. This is kind of what it looks like under an electron microscope. You can see that high porosity. So that high porosity makes it has the ability for it to absorb chemicals, retain water. So it's touted as a really important soil amendment for nutrient retention, water retention, and it can also be used in filtration. So higher forms of that you can use. Yes. In another great question. So the question was, where does the arsenic go? And this was a question I kept bugging my colleague. We need to look at the biochar and the hydrochar to see how much arsenic is in it. He was still in the process of purchasing a mass spectrometer that would analyze the arsenic levels. So he kind of had to wait until, but we finally got some data on that. And this is kind of, those are the numbers are the temperature treatments in degrees Celsius. And that's the starting arsenic. This one's a relatively low starting concentration, but as you can see, as the temperature is increased, that resulting hydrochar or biochar has lower concentrations of arsenic. And the arsenic is there is a distillate or liquid that's formed as a byproduct of that reaction. Likely that arsenic is in that leftover fraction. But the solid form of the biochar has much lower concentrations of arsenic in it. And the other thing to know too is that not all arsenic is toxic. So there's two ways that arsenic can get incorporated as a molecule in a larger molecule, is organic arsenic and inorganic arsenic. So organic means that it's got carbon molecules associated with it. Organic arsenic is largely considered non-toxic. Inorganic arsenic is highly toxic. So, and there was a study, again in Barbados, where they looked at what are the fractions of inorganic arsenic to organic arsenic. And they were finding ranges of anywhere from 50 to 60%. So we're already here getting close to that safe to use, at least in residential soils, and probably about half of that is non-toxic. So that's really promising.
So biochar is an agricultural product?
Yes. So biochar is being touted as being extremely impactful for use in agricultural applications. Our application is we wanted to use it, the biochar, as a way to, I mentioned earlier that we have a lot of issues with harmful algal blooms in Florida. We thought that maybe we could use it, introduce it to some of these bloom areas, maybe in controlled areas like marinas and canals, where it can sorb onto that algae and sorb onto the algal toxins if they're free in the water. Eventually that would settle out and make that issue, those harmful algal blooms, less available or not available to the environment, to harm animals, to harm people, that kind of thing. And that's kind of a conceptual diagram of how it might be applied. We had a graduate student do work in the lab with cultures of harmful algae species, and the results were very promising in terms of it being able to not only sorb onto the cells, but also remove the toxins that are freely floating in those culture dishes. So that was one application of biochar that we were interested in, kind of using a harmful algal bloom to control other harmful algal blooms. This is just an example of a company. This company is entirely based on producing biochar. They're U.S. based. I forget what state they're from, but these are the different applications of biochar that they are using their product for. They're mainly, their main starting feedstock that they use to make the biochar is rice husks. So they've got a never-ending supply from Asia, but they are interested in sargassum. So they're interested in seeing if they can use sargassum as convert it to biochar and apply it to some of their already existing applications. And these are just the range of applications that biochar can have. You mentioned agriculture. It can be incorporated into animal foods. It's actually for a lot of ruminants, a lot of cows, sheep. Biochar incorporated into their feeds has been shown to improve their food, their nutrient absorption. It's good for their microbiome in their gut. It's used as a soil amendment in agriculture to retain nutrients, retain water, and there's any number of different applications that it could be used for. So that's the kind of the biochar story, but I also want to go into some other examples of other people. In this case, Barbados. This scientist here is actually using sargassum, or it's still at the pilot scale, I believe at this point, but they can use sargassum and wastewater from rum distilleries to produce biofuel. And that's important because Barbados has a goal of being fossil fuel free by 2030. They only got 5 more years, so they gotta speed it up. But that has the potential to really have an impact for that island, not only because Barbados and you guys are probably familiar, has super high gas prices. So $100 just to fill up an average sedan. So that's one incentive. The other incentive is more global in scope, being able to remove that or remove that excess carbon or not make excess carbon available to the environment. So, which is good for the climate. So, another company, this one's based in Tampa. They actually provide sort of turnkey operation solutions for dealing with sargassum, all the way from removal to processing it on land and converting it to other usable forms like biofuel, things like that. So that's another example. This is a company that is on my side of the state in Florida called Seaweed Greens, and they're actually developing fertilizer from the excess sargassum. And they claim to have an arsenic removal system. I have no idea how they do it. It's proprietary, but that's another application. Being able to use those seaweeds to create new fertilizers, new products that are good for growing plants. And then these actually preceded all those solutions. This is a company in Mexico that's created bioplastics to incorporate into shoes. So that's a really unique. There's another company in California that's using algae to create algae-based plastics, algae-based foam, and they have a shoe as well. They're not using sargassum, but there's definitely potential there. There's a guy in Mexico who's developed adobe bricks out of using sargassum and is able to remove it right on the beach, process it not far away, and be able to build homes with it. And then there's another company that's created soap from it. I don't know the status of that one at this point in time. But there's an enormous potential and recognition of using these sort of waste feedstocks to make them into usable forms. Biofuel, biochar, all those different things. This is just an example of an institute that is trying to fund the people doing research on the feedstocks of the future. You know, what can we take? Whether it's sargassum, sugarcane chaff, the waste, agricultural waste, can we use that to create new ways to produce energy? And then even for this is just an example, just a little cartoon of this sargassum biorefinery concept. So being able to remove it, process it, and convert it into usable forms, and in a sense create a circular economy around sargassum. The Schmidt Institute is funding project ideas through that Feedstocks of the Future program, but there's also another smaller organization called the Algae Foundation that funds students, all the way from high school to graduate students, for trying to get new ideas on what to do about sargassum. And then there's other applications that have preceded even ideas using sargassum, regularly used in feed in Ireland. That's a product there. Kelp, probably from California, used as a nutritional supplement. A nutritional supplement developed from sargassum, a different sargassum species, bioplastics, compostable containers, all those kinds of things. And then what they find is that incorporating seaweed into cattle feed actually reduces methane emissions for cows. Technically it's their burps, not their, but I thought that was funny, so. And so this whole idea of valorizing, extracting value from this situation that's a problem, I think I hope to see, I showed you some examples of hopefully industries being generated around this. The biochar aspect of it, just so you know, that there are mobile pyrolyzers that can move around. There was a company in North Florida that was trying to sell the idea of just going to a beach, collecting it there, and then converting it to biochar on the spot. And they're still working on that. But this, going back to Uncle Scrooge's idea of extracting value from the Sargasso Sea, well, now the Great Atlantic Sargassum Belt. And I hope that kind of leaves you with a little bit more optimism about what can be done about this issue. So I'll stop here, but I'd just like to thank my colleagues at the University of Florida and Florida Sea Grant and Florida Institute of Technology. And with that, I'll take any questions. So if you don't mind, as extension agents, we are constantly having to evaluate our programs. So this is a quick survey, probably about 5 or 6 questions. If I don't know if we have internet, but if you can scan that and please fill that out. And again, and I'll take any questions. Yes.
Is there any sign of water temperature having anything to do with the growth of the sargassum? Because it seems to have been moving nearer to the equator.
Yes.
It doesn't it like cold water as you're going nearer the pole?
So the question was that what's the impact or the effect of temperature on the growth of sargassum, especially as it's in the equatorial zones? Increased warmer temperatures will make it grow more. There is still a seasonality component to it, where it does die back down a bit in the winter months, even though it's in the intertropical convergence zone, where the waters are still quite warm regularly. But in general, as we move into the later spring, May through July, it does increase. So the assumption is that the temperatures are increasing during that period of time, and so are helping stimulate the growth.
But it's not wanting to go into the colder.
No. So the question was, is it grow as temperatures get colder, and especially geographically? No, it's not. It's only sort of confined to that Sargasso Sea, where it's still pretty warm, even though you're kind of in the subtropics at the northern end of it. Yes.
My geography goes out the window.
So the question was, how about has sargassum moved south of the equator? Not to my knowledge. Maybe just around it, but not to my knowledge. I saw a hand raised in the back.
Related to that, I was wondering if climate change has played a role in everything going on.
So the question is the role of climate change in the sargassum phenomenon, correct? So that's tough to say, but one thing that is predicted with climate change is variability in climate variability in storms, which will cause so instead of consistent rain patterns, you'll have episodic rain patterns. Maybe higher and storms that come with that. So I think that it may be a little bit, the idea is maybe it's a little bit more indirect, but as you get more storms, you're going to get higher flushing of runoff from places like the Amazonian basin, which is going to keep fueling those that persistent bloom in the Great Atlantic Sargassum Belt. Yes.
A great talk. Any evidence that, I mean, it's a habitat for all these creatures. Any evidence that, like, after 2018, we got more sea turtles or more pelagic fish or more lobsters because they nest on it?
There's one study, again, I think it was in Barbados, where they were looking at, the question was, is there more, like, say, fish production, species production, as a result of expanded areas of sargassum? One study that I can recall, they looked at rafts of sargassum that were not yet close to shore, and what they were interested in is what natural resources, what species are there as a function of raft distance from shore, raft size, and what they were finding is that abundance of animals increases with raft size, and I think, if I recall correctly, abundance increases with distance from shore as well. But species diversity, for the most part, was more or less the same. The number of different types of species, regardless of raft size or distance from shore. Yes.
So my question is almost the opposite. For the Great Atlantic Oscillation that's coming in, it's bringing in all these species that are normally out in the Sargasso Sea.
Mm-hmm.
Would they have a decreased chance of surviving because they're in a non-traditional area for their, where they traditionally live?
So the question is, with sargassum moving into a new area and the species associated with it, will they have a decreased chance of survival or success in that new area? I really don't know. I don't know if people right now are focusing on solutions to the inundations and the beachings, but the fishery potential, that one study in Barbados sort of hinted at the fishery potential for particular species. I know in Florida, whenever I listen to fishing reports, and whenever they say the weed line, that's where you want to fish because that's where you're going to find your mahi. So whether that is starting to translate into increased fisheries production, increased population of sea turtles, not sure yet, as far as I know. Yes?
My question is, so if warm eddies are formed from the Gulf Stream, could they also have sargassum in and then move to the higher latitudes?
So the question is, if there are warm eddies, warm core eddies that can go into different areas, can the sargassum come with it? I don't know. I think that's entirely plausible. How warm, it depends on how warm it stays as it makes its way north. But whether that will lead to problems in newer areas, like more temperate areas, that I'm not sure. Yeah. Yes.
It might be totally unrelated, but is there plastic pollution? Is that a big problem for collecting the sargassum and?
Yeah, thank you for asking that question. So the question was, is plastic pollution a problem when collecting the sargassum? And the simple answer is yes. So I showed that picture of me shoveling sargassum, trying to collect it from that dumpster, and that it was collected from a net in a nuclear power plant intake canal. I will never do that again, by the way. I thought I was clever by wearing my waders, and it was in July, and I just about died. I think I almost fainted from doing that, so I will never do that again. But the one thing I noticed, I collected sargassum from the beach where I could. There's one beach in my area where it's known to accumulate because the currents just go that way, and unless the wind starts blowing the other way, it stays there. And this was just anecdotal, just by observation. But the sargassum that I collected from that floated in and was caught by the nets in the nuclear power plant intake had a lot of plastic material, a lot of wire leaders for fishing, a lot of just junk. And the beach sargassum did still have plastic pollution, but not nearly as much as the stuff. So when it's out there, that's a problem if you're collecting it out at sea. It's a problem either way, but it certainly plastic pollution is gonna be an issue of when you collect it. How do you properly sort that? Yes. Yes.
Me?
Yes. Okay. Yes.
I don't know if you touched this already, but because it's kind of related to the other questions, but does it also introduce new species to new areas? So that species go and travel with it, protected by the sargassum.
So the question is if new species are introduced into that new area. I don't know for sure. I just know a lot of the species that are normally associated with sargassum in the Sargasso Sea are also found in the Great Atlantic Sargassum Belt. But they could conceivably, that's within their range of temperature conditions to survive in those areas as well. But again, it begs that question, are there changes in populations in different species as a result of basically a new ecosystem that's been really started less than 15 years ago? Yeah. Yes?
You said that sargassum's accumulating arsenic. Assumedly it's accumulating it from the ocean while it's growing.
Yes.
Do you think it's having any effect in reducing arsenic levels in the ocean, or was the ocean just way too big for it?
So the question is sargassum helping remove arsenic from the ocean? The concentration, I think the concentrations in just seawater alone are so dilute, and I think it's the latter. It's a big ocean. A lot of seaweeds they have chemicals in their cell membranes, in their tissues, that are highly charged. They're highly negatively charged, called alginates, and so they naturally attract and accumulate metals. And sargassum, it just tends to be arsenic. So, yes.
Arsenic, the only metal causing flourish, or are there other heavy metals?
The question is, are there other metals that are accumulated by sargassum besides arsenic? Yes. So cadmium is another one that I can recall, and probably iron. I'm not sure about aluminum, but arsenic is the highest of that range of metal species that can be found. Yes. Yes.
You mentioned the asexual reproduction of the sargassum. Do they also reproduce sexually?
Yes. So the question is, does sargassum also reproduce sexually as well? Like all seaweed species, yes, they can, but it's thought to be the fragmentation and asexual reproduction is thought to be the primary way that it gets so large and becomes such a predominant feature in those areas of the ocean. Yes.
A practical one, because we have one area where it's accumulating a lot.
Yeah.
I think maybe years before as well, but the corals died in that area. Is there one advice you would give? Because it's always a debate, do you need to get it away or not? Because it's accumulating and accumulating and accumulating, so you can keep on going. But do you have an advice on this, or is it? It's a really big question.
Yeah. No,
and what to do with it?
Yeah, what to do with it?
Where to leave it?
The question is, that there's a particular area, is that the Cove Bay? Yeah, a particular area where sargassum is accumulating. What to do about it? If it can be kept away in some way from those areas, like where there's really important resources like coral. I'm not the technical person with regards to that, but potentially maybe those floating boom systems to kind of keep it at bay for a while but there's a lot of technical issues with being able to deploy those kinds of systems. Maybe that company, they're called BioImpact, that developed that system for U.S. Virgin Islands, is one of those companies to look at.
Hello. Let's have a wonderful round of applause for our I want to also have a shout out for our audience. There's a lot of new faces, so I hope you have all enjoyed a See and Learn presentation. I think you've given everybody a lot to think about. There's a real variance of people in the audience who will, I think, be taking home some good messages of how we can go from here. So thank you for being a great speaker and something that's really relevant to us. Before everybody runs away, Emily's put on the table as you exit. I think everyone's quite interested. So Vincent has two great handouts. One is about sorting sargassum and the wrack community. And maybe, Adam, you could put his microphone back on to tell us about the handouts and to also just give a brief idea about your field project tomorrow so that people who might want to still sign up can do so.
Sure.
And a quick thank you again to Calibre Cafe.
Cool. Thank you, Lynn. Am I on? Can you hear me? Okay, great. Thank you. I've got a couple handouts at the front there. One is just a little mini poster. This was printed. It was made and printed before the presence of the Great Atlantic Sargassum Belt, but it shows a lot of the different kinds of species that are associated with sargassum, and its ecological importance. So I have that, and then I have another handout that just shows the differences, morphological differences between the two species, three morphotypes. There's two types of Sargassum natans, Sargassum natans 3 and Sargassum natans 8, and then Sargassum fluitans. So if you're interested and want to be able to identify the different types of species, I've got a little key there for you. Regarding the field trip, so it's going to be tomorrow. It'll be a snorkel trip. If you've got an underwater camera or a housing for your phone, I recommend that. And I've set up an iNaturalist project. Has anybody used iNaturalist before? Yeah, it's a fantastic app. So I've set up a project called See and Learn on Saba, Sargassum project. So if you've got that ready, in my experience, it is easier. Oh yeah, I lost my.
Hello?
Hello? Okay. Okay, like this? Okay, great. Thank you. Regarding iNaturalist, it's very easy to use on your phone, but I find for myself, when it comes to like creating a project and setting it up, it's a lot easier for me to do on my computer. If you've got any other tips beyond that, let me know. But share your username with me. That's my email address. And then my username on iNaturalist is shown right there. And so you can find me and then look for that project. I think it should be fairly easy to join. You can take a snapshot of that. And we'll meet at 12:30 at the tent. Okay, great. And what I recommend too is, again, I can't remember exactly how it's set up, but make sure you're sharing your observations with sort of the larger community, and then that'll help us identify different things. And what I was really interested in setting this project up is to look at areas that before or during a period of time when there's no sargassum, and to sort of document what might be impacted on the next round of sargassum. Unfortunately, it looks like we've already lost some corals, but
but that was kind of the idea behind that.
Dinner smells fantastic, so let Liz or her team know if you want to stay for dinner. There's 2 types of pasta for only $15 each. And of course, it's really good to support our sponsors. Thank you, everyone. Have a great night. See you Friday at Liam's Cuisine for our speaker who's going to tell us all about the night sky. And his field project promises to show us Saturn. So stay tuned. Wondering, loosen you up.